Hey guys, it's Sahil, and I'm going to be walking you guys through the new Mastering Engineering assignment, Mastering Engineering 8, starting with question 2. I don't know why, but question 1 just hates me. I couldn't do physics question 1 for the longest time, and I can't do the question 1 on this one yet. The other two questions are fairly simple, so I'm just going to be walking through the solutions with you guys. So this question is the question of the dad, I'm presuming, pulling the boy up the tree limb. So let's just get this equation, let's just get the diagram drawn here. It's up here. It's going to be, we got point A, point C, and point B, which is not quite in line with point A. And we have a rope going from point B around point C to point A. Now, what information are we given? I'm just going to show you guys what information we're given. We're given velocity this way. We are then given the total length of the rope, which I'm going to call L. And then we are given height. This height here, which is in line with A. Right? Now what we're asked for is velocity K. I call it velocity K because he's a kid. You know, the kid going up. Kind of makes sense. So, this is basically, if you kind of know what you're doing, this is a related rates question. You should recognize this. So I'm just going to go ahead and quickly show us what we're going to do here because it might not be very straightforward. You're going to take this length here. I'm going to label this LAC. And then we're going to take this length here. What's it? Length of BC. And we're going to find those in terms of all these variables. And the reason I haven't given any numbers is because everyone has different numbers. If I say dude with like, you know, the guy's like 1.4, like 2 meters per second, or like maybe he's sprinting at like 20 meters per second, I don't know. But yeah, like people might get a bit confused, so I'm just going to leave everything in terms of variables. And I'm going to, and in the end, the expression that I get should be only of what we're given. So if there's any unknowns in there, then I did something wrong. So let's get started. The length of AC is, now, if you look at this, oh right, I forgot to label X and Y. Y is the height of this rope here, and X is this distance here. That's what they tell us to equate X to, so we're going to listen to them, X and Y. We're going to listen to them because, you know, we like to listen to people. I'm just kidding. But moving on. So we see here that as X varies as he moves, the length here, length AC, is always relative to X and H, you know, from a triangle. This length here of the rope doesn't affect that length because the triangle composes of X and H, not Y. So length of AC is equal to root X squared plus H squared. Now, if you're having problem seeing where this comes from, then I think you should probably go back to like grade 8. Moving on, length of BC. This length here is, it's an easy one to solve for. It's just Y, because, you know, Y is the length of the rope. That's just what it tells us to define it as, the length of the rope there. So now we're going to find the equation for the length of the total rope. Length of the rope equals length AC plus length BC. Now we're given length, and we just calculated that, the LAC and LBC. So we'll just plug it in. And plus Y. Now, we're just going to isolate for y, so we get a function in terms of x. We're going to getting y equals the length minus x squared plus h squared. Okay. So now we've come up with an equation in terms of y, relating it to all the givens, to everything that we were given, except for x. I guess we're not really given x, but we're given a numerical value for x, and we're given the velocity at which x changes. So essentially, we're given everything we need for x. So I'm going to use pink here because I'm awesome. Take the derivative. That's how I write the derivative. This on this side should be dy dt equals derivative of L is 0. And if we take the derivative of this, I'm not going to go through all the work. So I'll just tell you what the derivative of this is. You end up getting negative x over root x squared plus h squared times dx dt. It's not hard to see where this comes from, but remember, when you use a chain rule, since we're taking derivative in terms of time because we're trying to find velocity, you have to multiply by dx dt. You have to, or it's just not going to work. So after this, plug in your numbers, because we know what dx dt is, right? It's just v of a, and this is v of k. So v of k equals negative whatever x value they want, x squared plus h squared times v of a. Now, your answer you're going to get, if you notice, is negative. And that makes sense because if you go back up here, v is getting shorter. And v is, v is getting shorter, so I guess its length changing is negative. Really, it's just a negative, just shows the direction. Doesn't really matter because the question just asks for the absolute value. So, there's our final answer in pink. Yeah, because that's how we roll.